During the beam deflection video review, link below, we calculated the slope of a composite beam at the free end C for when it was set up as a cantilever beam. The transformed section elastic modulus and second moment of area I were calculated and used to determine the angle of deflection at C. We did it using singularity functions. In this video, we'll calculate that angle using Castigliano's theorem. This is the first example for the Castigliano's theorem main video, link below. From that main video, we know that we can calculate a deflection in the direction of the force if we take the partial derivative of the strain energy with respect to that force. But we also learned that we can calculate the angle if we take the partial derivative of the strain energy with respect to the moment. This is what we'll use here, and we'll only use the strain energy due to bending, since we know that the energy due to transverse shear for a long cantilever beam like this is always negligible. The angle at C will therefore be the partial derivative of the integral, which in this case is the same as the integral of the partial derivative. Since the function for m is different from C to B than from B to A, the integral will be split into two. And notice that when using Castigliano's theorem, your x equal to 0 starts at where you're calculating either the deflection or the angle, in this case C. The moment between C and B will be equal to minus 2x, and the moment between B and A will be equal to minus 2x from the same point load, plus the equivalent point load of the distributed load times the distance to where that equivalent point load is located. Simplifying this expression and carrying out the integrals, we can substitute the values for the